Hello students, today we will see the next concept of design concept chapters. Concepts is information hiding. Information hiding is the fundamental design concept for the software. The principle of information hiding suggests that module be characterized by a design decision that hides from all others. In other words, module should be specified and designed so that information like algorithm, data, etc. that contains within a module which is inaccessible to other modules that have no need for such information. Hiding implies that effective modularity can be achieved by defining a set of independent modules that communicate with one another. Only that information that is necessary to achieve software functions because of most data and procedures are hidden from other parts of the software, and it is inadvertent errors introduced during like modifications are less likely to propagate to other locations within the softwares. Modules should be specified and designed in such a way that the data structures and processing details of one modules are not accessible to other modules. Here, the IEEE defines the information hiding as the technique of encapsulating software design decisions in modules in such a way that the module's interface reveal as little as possible about the module's inner working, such thus that each module is a black box to the other modules in the system. These modules should be specified and designed in such a way that the data structures and processing, which is details of the one of the modules which are not accessible to other modules. They also pass only the informations to each others which is required to accomplish the software functions. The main use of information hiding as a decision criteria for module system which is provide the greatest benefit when modifications are required during testing, then later during the software maintenance. Because of most data procedures details are hidden from other parts, so the software inherent errors introduced during modifications. Here the way of hiding is unnecessary details is referred to as information hiding, and hiding defines and enforces access constraint to both procedural details within a module and any local data structures used by the module. Then next is functional independence. In software design, the concept of functional independence is a direct outgrowth of separation of concern, modularity, and the concept of abstractions and information hiding. The functional independence is defined as a direct improvement or enhancement to the concept modularity, abstractions, and information hiding. Here the functional independence is achieved by developing the modules with a single-minded functions and a version to excessive interactions with other modules. The functions independence is also stated in other ways. We want to design the software so that each module addresses the specific sub-functions of requirement and has a simple interface when viewed from other part of the program structures. Independence is important because software with effective modularity, that means the independent module is easier to develop because the functions may be comparable in and interfaces are simplified. Then independent modules is also easier to maintain because the secondary effect caused by the design and code modifications are limited, like error progressions are reduced and it is reusable modules are possible. Then the functional independence is a key to good decision and design is the key of software quality. Independence is assessed using the following two qualitative criteria like cohesion and coupling. Then cohesion is the an indications of the like relative function strength of the module, And also cohesion module performs a single task requiring little interactions with other components in other part of the program. Then second is coupling. Coupling is a indications of the relative interdependence among modules, and coupling depends on the interface complexity between modules and the point at which entry or the reference is made to module and what the data passes across the interfaces. The next concept is refinement. The stepwise refinement is also called as the top-down design, which refers to the progressive refinement in small steps of the program specification in a program. A refinement is the process of elaborations. That means the hierarchy is developed by decomposing a microscopic statement of the function in a stepwise fashion until the programming language statements are reached. Refinement is actually a process of elaboration, and we begin with the statement of the function descriptions of the information that is defined at a high level of the abstraction and reached at the low level of abstraction. In each step, one or several instructions of the given programs are decomposed into more detailed instructions. Abstractions and refinement are complementary concepts. Then the stepwise refinement is the top-down design strategy, which is used for decomposition of the system from the high level abstractions into a more detailed level, that means low level abstractions. At the highest level of abstraction, function or information is defined conceptually without providing any informations about the internal working of the functions or internal structure of the data. As we proceed toward the lower level abstractions, more and more details are available. Then the software designer start the stepwise refinement process by creating a sequence of compositions for the system. Then it is designing. Each composition is more detailed than the previous one and contains more components and their interaction also. Abstraction and refinements are the complementary concept, and it is enable for designer to specify the procedure and its data, and it suppress the low level details. Refinements help the designer to reveal the low level details as a design progresses. The earlier composition which represent the significant interactions with the systems, while later composition show details how these interactions are achieved. Then next concept is aspect. As requirement analysis occur, a set of concerns is uncovered. These concerns includes requirements, use cases, features, data structures, quality of service issues, variants, intellectual properties, boundaries, then collaborations, patterns, and contracts. Ideally, a requirement model can be organized in a way that means that allows us to isolate each concerns. Concerns means their requirements, so that it can be considered independently. In practice, however, some of these concerns span the entire system and it cannot be easily compartmentalized. And as the aspect of the program is a features linked to many other parts of the programs, but which is not related to the programs like primary functions. An aspect cross-cut the program core concerns. Therefore, violations its separation of the concern that tries to encapsulate unrelated functions. For example, a logging code can cross-cut many modules. Yet the aspect of logging should be separate from the functional concerns of the module it crosses cut. Then next is a refactoring. Refactoring is a reorganization technique that simplifies the designs or internal code structures of component without changing its functions or external behavior. It removes redundancy, unused designs elements, inefficient or unnecessary algorithms, poorly constructed and inappropriate data structures, or any other design failures. Then software design may decide to refactor the components into the 4 different components, each exhibiting high cohesion and this leads to easier integration, testing, maintenance of the software component. For example, a design model might yield a component which exhibit low cohesion, like component performs four functions that have limited relationship with one another. After the careful considerations, we may decide the component should be refactored into the three separate components and each exhibiting high cohesions. The result will be software that is easier to integrate, easier to test, and easier to maintain. That's why refactoring is used. Then object oriented design concepts. Today, the object oriented paradigm is widely used in the modern software engineering, so that the software object oriented concepts are used in the design methods such as the classes, object, polymorphism, encapsulation, inheritance, dynamic binding, information hiding, interfaces, and so on. To understand the object oriented analysis, the following concepts must be known. First is object. Object is an instance of a class and it is used to describe the real world entity. Then second is class. Class is a collection of similar objects. Then third is attribute. Attribute is the collection of the data values which describe the state of an object. Then for this operation are also known as a method and services. It also provides a means to modify the state of the class. Then inheritance. Inheritance is the process in which an object inherits some or all the features of the superclass. Then last one is the polymorphism. Polymorphism is an ability of object to be used in more than one form. The main advantages of the object oriented design is that improving the software development and their maintainability. The main advantages of object oriented design is that improving the software development and also their maintainability, and also it is faster and low cost development. So it is also creates a high quality software. And one of the disadvantages of object oriented design is that larger programming size and it is not suitable for all the type of the programs. Then next is design classes. The analysis model in software engineering defines a set of analysis classes, and each of these classes describe some elements of the problem domain, focusing on the aspect of the problems that are user visibles. The level of abstractions of an analysis class is relatively high, and as the design model evolves, we will define a set of design classes that refines the analysis classes by providing design details that will enable the classes for the implementations, and when we implement the software infrastructure that supports the business solution. Then the set of design classes refine the analysis class by providing design details, and there are the 5 different types of the classes, and each type represent the layer of the design architectures. Then first is user interface classes. These classes are designs for human computer interaction, that means SCI. These interface classes defines all abstraction which is required for human computer interactions. Then second one is business domain classes. These classes are commonly refinement of the analysis classes. These classes are recognized as attributes, their methods, and which are required to implement the elements of the business domain. Then third is process classes. It implement the lower level business abstractions which is needed to completely manage the business domain class. Then fourth is persistence classes. It shows the data stores that will persist behind the execution of the software. And the system classes implement the software management and control functions that allows to operate and communicate in computing environment and their outside world. And then last one is system classes. The system classes implement software management and control functions that allows to operate and communicate in computing environments and also outside the worlds. And here some characteristics of the design classes. The characteristics of well-formed design classes are as follows. First one is complete and sufficient. A design class must be total encapsulations of the all attributes, their methods, which are required to exist for the classes. Then second one is primitiveness. The methods in the design class should be fulfilled one service for the classes, and if services is implemented with a method, then the class should not provide another way to fulfill the same things. Then high cohesion. A cohesion design class has a small and focused set of the responsibilities, which is used for implementing the set of responsibilities. The design classes are applied in the single mindedly to the methods and their attributes also. Then last is a low coupling. All the design classes should collaborate with each others in a design model, and the minimum acceptable of collaboration must be kept in this model. If a design model is highly coupled, then the system is difficult to implement, also to testing and to maintain over the time. These are the characteristics of the design classes. Then next concept is dependency inversion. The structures of the number of older software architecture is a hierarchical. At the top level of architectures, control components rely on lower level worker components to perform various cohesion tasks. For example, consider a simple program with three components. The intent of the program is to read keyboard stroke and then print the result to the printer. A control module C coordinate two other modules, that means a keystroke reader module and module with write the printers. Then this is the dependency inversion. And last is design for test. The R. Brock writes, advocates of the test driven development TDD write the test before implementing any other codes, and they take to heart Tom Peters' credo: test fast and fail fast, adjust fast. This testing guide they are designed as they implement in short, rapid fire, write test code, fail the test, then write enough code to pass, then pass the test. This is the cycle. But if the design comes first, then design, that means coding, must be developed with sim locations in the details design, and where you can insert test code that probes the state of the your running softwares, and also isolate the code under the test from production environment so that you can exercise in the control testing context. Then the in the short, you need to provide the appropriate test affordances, and they are factoring your designing in a way that test code integrate and control the running system.